In this video, we're going to discuss how to find critical values from the t-distribution. Right? So remember, critical values from the standard normal, this was the distribution of the standard normal, for example, centered on 0, and then our critical values were the values that separated the values of z that were likely from the values of z that were unlikely in the tails, right? So now when we're talking about for the t-distribution, so this used to be the distribution of z, right, which was standard normal distribution with mean 0 and variance 1, right? So now we're going to change this to talking about the distribution of t. The t-distribution is very similar to the distribution of z. Some differences are it has slightly thicker tails, right? So this one, maybe the tails crash a little faster. This one has slightly thicker tails, but actually as the sample size increases, the distribution of t and the distribution of z are the same. Right. Well, actually, there you go. There's another difference between the distribution of t and the distribution of z. The distribution of t depends on sample size. Okay, so you need to give it particular degrees of freedom, and degrees of freedom is n minus 1, the sample size minus 1, and then you can figure out which distribution of t you're going to be using. All right. But the critical values is the same. Sort of cutoff between the likely values of t from the unlikely values of t. All right, so you still have here you would have 1 minus alpha in the center, and then alpha divided by 2 on each tail. Same deal here, 1 minus alpha in the center, and alpha divided by 2 in each tail. And this is the positive version of the critical value. That's one we always provide, and then this is the negative version. All right, so let's go ahead and do some examples where we're finding critical values for a 95% confidence interval when the sample size is 15. Okay, so the distribution of t depends on this thing called degrees of freedom. So we need to figure out what this degrees of freedom is. It's n minus 1. So in this case, sample size is 15. 15 minus 1, 14. All right, 95% is in the middle, which means I have 0.025 in each tail. All right, I'm looking for this value of t right here. So let's go to our t table and look this up. Okay, so here we go. Here's our t table. Now, t table, it will give the area in one tail, right, which is that 0.025, but it'll also give the area in two tails, which in this case is 0.05, right? And there's these visualizations to the right that kind of remind you that this is two tails. One tail would just be the area that's in one of the tails. Okay, I recommend looking into this area in two tails. So if you're talking about 95% confidence interval, the total area in the two tails is 0.05. So that's what you should look at. Okay, so that way you just need to do 1 minus 0.95, and then you know, okay, 0.05. That's what I need to be looking at. All right, my degrees of freedom was 14. So I go down to the degrees of freedom 14, and I look where the area in two tails is 0.05. Here we go. This is my critical value, 2.145. Let's go ahead and write that down. Okay. 2.145. All right, so there you go. That's my critical value. Pretty easy to find. All right, let's do another example. All right, so now we're talking, we have sample size of 10, so I need to consider my degrees of freedom. All right, so 10 minus 1, so that's 9. Okay, so here's my cutoff. I have 0.9 in the center, so that means my area in both the tails is 0.1, right? This is 0.05 and this is 0.05. So, but the area in both the tails is 0.1. So let's go to my table. Okay, so the area in two tails is 0.1, because 0.9 is in the center, so 0.1 is in the tails. All right, my degrees of freedom is 9. So I go over down to 9, 1.833. That's my critical value. So t alpha divided by 2 is 1.833.